Okay folks, a lot of you had questions regarding the curriculum mapping that I decided to make this video for you, and let's hope that this helps you to see how you map a curriculum. Well, curriculum mapping is basically looking at what is in the curriculum, how it overlaps, what knowledge it builds across the years, and particularly we're looking at the solving of equations. I decided to use the solving of equations in the CAPS FET curriculum just to give you an idea of how this works. Okay, so we start off by looking at what I call the fit in the curriculum assessment. If we look over here, our algebra and equations and inequalities are in grade 10, 30 to 33 marks, grade 11, 45 to 48, and in grade 12 again 25 to 28. So you'll see it counts more here in grade 11 than what it does in grade 12. I'm not sure why, but we'll have a look as we go through the program. So that I found on page 10 of the CAPS curriculum. If you then go further down the curriculum, you will find something that's called the overview of topics. That is on page 12 and page 13. Now I decided to include in here the pre-knowledge. What is necessary to know before we can move to the focus, which I call the focus knowledge, and that is the solving of equations. Okay, so it might make sense to include that at the curriculum or at the overview of topics if it is essential to include. In our case here, I think it was a little bit more information that I needed to be able to talk about the focus knowledge more in a more authoritative way. Okay, so if we look at that focus knowledge now, and we see what the curriculum looks like over here. I'm just going to move myself out of the way there. Let me move myself in that little space, and I'm going to fetch my highlighter again. There we go. Okay, so if I don't have it. There we go. I have my highlighter, yes. So I've got grade 10, grade 11, and grade 12 in 3 columns. Now I suggest you do that. Okay, so this is what I call round 1 of the mapping. If you look in the curriculum, you'll see it says revise the solution of equations, solve quadratic equations by factorization, solve simultaneous linear equations and 2 unknowns, solve word problems with linear, quadratic and simultaneous linear equations. So word problems, the key issue there. Solve literal equations, in other words those where you change the subject to the formula. Solve linear inequalities and show solution graphically, and you must also be able to work with it in interval notation as well. Okay, now as a maths teacher you should know what that means. We'll talk about that if you don't. In grade 11 we have completing the square, quadratic equations by factorizing, quadratic inequalities and 1 unknown. They say here it's important that the solving of equations and 2 unknowns is important to be used in other equations like hyperbola, straight line, etc., where you work with graphs, the functions. Okay, and then point 4, equations and 2 unknowns, linear and quadratic equations, and then they talk about the nature of the roots. Now folks, you'll see here in grade 12, if you look in the curriculum document, the topic allocation per term is what we're looking at. There is no real allocation in grade 12 for the solving of equations. So let's go back here and let's now see how do we develop. This is the map here. Well, let's see. First thing here, it says revise the solution to linear equations. Nothing of that is mentioned. So it remains under grade 10 in its own block. Now it says solve quadratic equations by factorization. Here, quadratic equations by factorization. So look at what I did in the map. I merged my two columns because the solving of quadratic equations, and I bold the quadratic equation so it stands out to the reader. A, by factorization, because that happens in both grade 10 and grade 11. I'm sure it will happen in grade 12 as well. But now in grade 11, it says by using the quadratic formula. So I carried on underneath grade 11 and I included the quadratic formula. Okay, we'll look at this last one that I put in here just now. Okay, so this should actually read B and that should read C, if I'm correct with what I want to say. So let's read on. Solve simultaneous linear equations and two unknowns. Well, the issue is simultaneous linear equations. Now, is anything mentioned over here about solving simultaneous equations? Here they say equations in two unknowns, one of which is linear and one which is quadratic. Okay, so here they're talking about the solving of equations in two unknowns. Okay, so it is similar to what we're mentioning here. So solving of equations in two unknowns, linear equations in two unknowns, runs across the 2 years. But now, for the grade 11 year, it says include combinations of hyperbolic, which is the hyperbola and linear together. So we say we include hyperbolic and linear, and we also include the linear and the quadratic, only in grade 11. So where the entry in the curriculum document talks to both grades, I merge the line, the two columns. And then when they separate in that discussion, I keep it particular to a grade, whether it's grade 10 or grade 11. Then it says here we solve, so we've dealt with simultaneous equations. We solve word problems involving linear, quadratic, and simultaneous linear. So here they talk about quadratic, linear, and simultaneous linear equations. So if we have a word problem, it can have linear, so I'm highlighting the notion of a word problem, linear, quadratic, or simultaneous equations. Nothing is said over here about that, okay, which is important. We'll talk about that in our next round of mapping. Okay, so then solve literal equations, nothing mentioned in grade 11, so we only include it in grade 10. Then it talks about inequalities. So here it says linear inequalities and show the solution graphically. Interval notation must also be known. Now you know that if you solve an inequality, you can end up with x is bigger than equal to 1, smaller than equal to 2. So you must be able to express it like that, or x is an element of closed interval 1, 2, closed interval at 2. So closed, interval notation. Nothing is mentioned here but quadratic inequalities in one unknown and interpret. No quadratics in grade 10. So we only include that under grade 11. Okay, so that concludes round 1. Now we go to round 2, folks. Round 2 talks about the topic allocation per term, but now you'll see if we will work with topic allocation, if you go further down, in your curriculum, you will see that it gives you examples of what they mean. Okay, so there's quite a few examples given here. Now let's quickly look at grade 10. There's examples using fractions. Then there's normal quadratics. Now notice with this quadratic, the leading coefficient is not 1, which is interesting. solve for x and y, so that's two linear equations, and they show you here that you can problematize the linear equations by including fractions. Then the literal equations, solve for r in that equation v is equal to pi r squared h, so isolating one of the variables. And then solving linear inequalities, that's called a simultaneous inequality that we talk about. Okay, so that's for grade 10. They also continue later on and they put this under exponents, which is interesting because it's also equations. Okay, so what are we doing now? We're reading on through the curriculum content to see are there any other equations that are included. And we see here with exponents it is. Now look at this, very interesting. That one involves logs in grade 10. Now if you speak to any teacher, they would say, no, it's not in the curriculum for grade 10s. Only 11 and 12. CAPS curriculum includes it in grade 10. So you need to read beyond the surface. Okay, this one, what is difficult there? Well, it's the rational power. Here, we've got another exponential equation where we need to take out common factors. And then we have an exponential equation that has a quadratic form. Very interesting. Under solving of equations. Let's go to grade 11. Here they give you a problem. They say, I have 12 meters of fencing. What are the dimensions of the largest rectangular area? Now don't read past the detail when you do a curriculum map. If they ask you for the largest whatever, they're talking optimal solutions, meaning they're either after a maximum or a minimum, which is beyond the surface. You need to read carefully. Okay, let's read on. Show that the roots are rational. Interesting. Show that the roots are non-real. So what is this bringing in? This is bringing in the nature of the roots under the solving of equations. Here, solving of quadratic inequalities of that form, not much to say about that. But look at this last one. It looks like these two things are the same. They're not. This works with optimum solutions. The second type of word problem which they're talking about over here works with rates. How long does the slower machine take on its own? So what do they say? They say together the machines can do it in so many hours. If one machine works by itself, it can do it in that amount of hours, and the other one by itself is what they are asking for at the end. So those work with rate, works with rates, rate at which you can perform a job, the rate at which you can print a book, whatever the case is, it's rates. Look at this now, interesting. Under exponents they include this type of equation. They say solving simple equations using surds, posted under exponents. Now folks, the only thing exponential here is that power is a half. That's all. This usually turns into a quadratic equation once you try and get rid of that power. Very interesting. Okay, so don't forget, you have to read on, you read beyond the surface. Now remember in the previous slide I had a big question mark here, and look at what pops up in grade 12. The solving of an exponential equation that uses logs. That was on page 41, I think. Page 44, they say any method can be used to factorize third-degree polynomials, but should include examples which require the factor theorem. Now that's interesting. First time it's mentioned that you need this information when you work with calculus and cubic curves. And there's the first thing, solve that cubic. Or solve a variable with certain information given about that cubic. That's equation solving for you. Okay, no matter how you look at it, you're going to solve an equation. So this concludes round 2 of your mapping, looking at the allocation per term through every grade and looking in detail and reading beyond the surface. Now with that information, I've deleted the initial stuff, and this is what we had so far in our curriculum map. You will notice my grade 12 is still empty. Now let's see how I've changed things over here. Having included the stuff I've seen in the curriculum documents, remember what I said. This is a simultaneous linear inequality. This suggests the use of logarithms in grade 10. This suggests rational powers. This is a common factor problem. That's a quadratic form. This here is an equation with surds. Okay, the largest rectangular area, optimal solutions. How do we use this? How long does a slow machine take by itself is a rates question. And here in grade 12, again, the idea of the factor and remainder theorem coming in to solve cubics. Now let's see how that changed our curriculum map. There it is now. All the yellow is what I added. Now look at this. The completing of the square. I said in the beginning, I'll talk about that. To complete the square, you use that information and functions when they work with grade 11 parabolas. But you can also be asked to solve an equation through the completion of the square. Very interesting. Okay, so all the yellow has now been added here to my curriculum map to accommodate my further reading that I did when I looked at the examples that they gave for content. Okay, so this is the final part of my curriculum map. Folks, I hope that helps you and with your curriculum mapping.